Welcome back to the number guessing game solution video. So how did you get on? Hopefully you managed to give the project a good go and even got a working solution at the end of it. If not, hopefully you managed to give some parts of the project a go and only got stuck in a couple of places. However you got on, it's important to keep practicing and persevering. The main objective here is to improve our problem-solving skills by utilising the skills we've picked up so far during the course. Now, what I would say is that embarking on a project can sometimes be quite daunting. Even knowing where to start can be difficult, but a great way to approach any program or problem is to break it down into smaller bite-sized problems that we can tackle individually. We can then piece it all together at the end to hopefully get something that works. Now, I say to all my students who start coding their own solutions to adopt a give it a go attitude. Don't worry about making mistakes. Don't worry about running into errors. In fact, it would be worrying if you never made a mistake in Python. Some people are scared of failure and are hesitant to give it a go because they are scared of what people may think, or are embarrassed because they're perceived to get something simple wrong. Remove this mindset from your head. This is a safe space to give anything a go, and there is no such thing as a silly question. So if you have anything that you want clarifying after this video, please feel free to reach out and we'll try our hardest to get your understanding back on track. By producing solutions to projects and working through solution videos, it will only reinforce what we've learned so far, and hopefully it will act as a nice way of solidifying your knowledge. So far we've learnt the enablers that help produce these programs, but we're now making a transition to using these enablers to code up real solutions to real problems. It's always the fun part, but can also be scary. So when you sit there and think, I don't know where to go next, just remember there is a wealth of support in the Python community who can get your understanding back on track. But in this video, I want to share with you my thought patterns and the solution that I put in place. You should recognize every line of code that we write, as we have covered it all. So with that being said, let's create a solution to the number guessing game. So the first thing we are asked to do is to get the computer to generate a random number. So the first thing I think of here is that we'll need to take advantage of the random module and use the randint method that we've seen previously. And this will enable us to generate a random number that we can store in a variable. Now, we're not told here the range of numbers that we should be generating a random number from, so in this example, I'm going to generate a random number between 1 and 100. So first things first, we're going to import the random module. And this is done by putting the keyword import followed by random. We can then run the code cell. Next, we can use this module to generate a random number. So we can put random, then we can place a dot, and we can access the randint method. We can then open up parentheses, and then inside parentheses, we can put the starting number and finish number that we want the random number to be generated from. So we'll put 1, 100. Now, in order to store the result of this random number, we can assign this to a variable. So we'll call the variable num, and then we can put the assignment operator. When we run this code and then take a look at what's stored in the num variable, you can see that we generate 47. And if I go back up to where we generate the random number and rerun this code, and then take a look to see what's stored in the num variable, you can see we get 59. So our random numbers are being generated in between 1 and 100, just as expected. Okay, so we know we're going to be using this later on in our code, but let's now tackle step 2. We're asked to allow the user to submit a guess. So how do you think we go about doing this? Well, we've seen that we can collect user input by using the input function. So we'll start by putting the keyword input, and then we'll put a prompt which tells the user to guess a number between 1 and 100. We can then put a colon and a space. What we will then do is pass the result of this method into a variable called guess. So we can put guess equals and then the input function. Now we know that when we collect user input, it is by default a string object. So in order to convert this into an integer, we can pass this into the built-in int function. Now I could put this on this same line, however for clarity, I'm just going to put it on the line below. So I'm going to set guess equal to the int of the variable guess. When I run this code, you can see we're asked to guess a number between 1 and 100. So if I put in the number 50, and then take a look at what's stored in the variable guess, you can see that we get 50 returned. So now not only are we generating a random number called num, but we're also generating a guess submitted by the user and storing it in a variable called guess. And just to prove that guess is of the int data type, we can pass guess into the type function, and you can see that we are indeed working with an int object. Okay, so far, so good. Next up, we're asked to produce the game logic. And in order to produce this, i.e. compare one value to another value, the first thing that comes to mind is the use of conditional statements. So we've already defined guess and we've already defined num, and at this moment in time they also both store a specific value. So let's first of all produce the conditional statements. So I'm going to first compare to see if guess is the same as the num variable. In other words, the user's guess is the same as the randomly generated number that we've stored in num. If it is, I want to print out congratulations, you guessed correctly. Next up, I want to type elif the guess is greater than num. I'm going to print out you guessed too high, because guess is higher than num, and therefore try a lower number. Else, if guess isn't the same as num and guess isn't greater than num, everything else must therefore be a lower guess, so we can print you guessed too low. Try a higher number. Okay, so if I now run this code as it is, you can see we bring back you guessed too low. Try a higher number. Now this is because the value currently stored in guess contains the value 50. And we know that the randomly generated number that's stored in num is currently 59. So because our guess is lower than num, the else statement is executed and we print you guessed too low, try a higher number. Now so far this doesn't lead to a very dynamic game, and we would want the user to guess another number if they got something wrong. And this is where I'm thinking the use of a while loop will come in very handy. So if we go back up to this code cell and then indent this logic, we can then start this code cell with a while loop. And we want this loop to keep going while guess does not equal num. So while the user's guess doesn't equal the number, we want to keep going over this conditional statement. But the first thing we want to do is actually get the user to guess by putting in an input. And this is where the logic that we've written above will come in handy. So after the while loop's colon, we can copy and paste the logic that we've written above and place this straight after the colon and before our conditional statements. So when we now run this code cell, you can see we're asked to guess a number between 1 and 100. Now we know the value in num is 59, so this is quite an easy game. But if I once again put 50, you can see that we've guessed too low. Try a higher number. So we've gone through the logic, it's seen that we've guessed too low, and therefore the else statement is executed. We then go back up to the while loop, and because guess, which currently stores 50, does not equal 59, we're then asked to input another guess. So let's put the number 65. You can now see that we've guessed too high. Try a lower number, and once again, because guess is now greater than num, it's executed the elif statement. We've then gone back up to the while loop, And because guess still doesn't equal num, we are asked to input another number. Now let's suppose I guess correctly and I put number 59. You can now see that because guess equals num, we've printed out congratulations, you guessed correctly. We then go back up to the while loop, and because guess now equals num, this statement evaluates to false and we break out of that while loop. Hence we're not asked to input another guess into this while loop. So it feels like this game logic is working as we would expect it to. I'm happy with it, so let's now tackle the next part of the project. The fourth step told us that a player should only get 5 guesses. Once the guesses run out, the game is over. Now in our current while loop that we have above, we would get as many guesses as we would like, and the game would get quite boring, because we just have to keep guessing based on the message that the computer gives us, and we would eventually get the answer. Not very fun. So we now need to tweak our logic so that the game ends when we've run out of tries. So to start with, we'll create a variable called tries, and we will set this equal to 5, i.e. the amount of guesses that we're allowed to have in this game. We will then copy and paste the while loop and the conditional statements and enrich it accordingly. So my first thought is that if a guess is greater than num, or if a guess is less than num, we need to reduce the value that's stored in the variable tries by 1. So in the elif statement after the colon, I'm going to put tries minus equals 1. Because we know that this will then deduct 1 from the value that's currently stored in tries. I can also do the same in the else block, so after the colon I can put tries minus equals 1. Okay, so in our current while expression, we have put while guess does not equal num, then perform the following code block. But we also now want to add in a second expression that checks to see if we have any tries remaining. So inside the while loop's header, I can add a second condition that says and tries does not equal 0. So let's think about this from the start. Tries would originally contain the value 5. And if we guessed 50, which we know doesn't equal 59 based on the current randomly generated number, and tries doesn't equal 0, well it equals 5, so this is also true, then we would execute the following code block. Now if a guess was wrong, i.e. it was greater than or less than the number, we would deduct 1 from tries. Tries would then contain 4. Guess wouldn't be the same as num, and therefore because tries doesn't equal 0 as well, it contains 4, we then execute the code block again. If guess equals num, we break out of the loop because one of the conditions evaluates to false, i.e. guess does equal num, therefore guess does not equal num would evaluate to false. And if we got to the point where we only had 1 try left and we guessed too high, tries would then contain 0, and because tries would evaluate to 0, the second condition would evaluate to false, and therefore we would not continue with the while loop. So let's now run this code block to see what we get. Now when I run this code block, nothing happens. Can you guess why? Now if you're thinking, well it's because the while loop has a condition which evaluates to false, you would be correct. Guess currently equals num, and therefore the while loop doesn't execute. So if I go back up to where we've defined guess and rerun this code cell, we can change the value stored in guess to be the value 10. If I now try to execute this code block, you can see that we're asked to guess a number between 1 and 100. So let's put 50. You can see we've guessed too low, try a higher number. We know the value's 59, so let's go a little bit too high. Let's put in the value 80. Okay, so that's too high and that's 2 guesses. Let's put in 70. Okay, too high again, let's put in 65. Okay, too high again, let's finally put in 60. Okay, so once I've guessed 60, i.e. my fifth guess, you can see that I no longer have the option to input another guess. This is because tries now equals 0 and therefore we've broken out of the while loop. So we're now only allowed to have 5 guesses before the while loop stops. Now it would be quite nice if we also got a message after we had used up all of our tries. And the way we can do this is just by enriching our current conditional statements. So if we go up to the conditional statements, I'm going to leave my if statement to check whether guess is the same as num. But the second condition I want to check is that if guess does not equal num, i.e. it's bigger or smaller than num, and tries equals 1, i.e. we only have one try left at this point, then I want to print out better luck next time. And then I want to use the break keyword to break out of this loop, because at this point this elif statement would be executed. And because I know it's their last try, I can simply break out of the loop without the loop checking the while loop's expression. Now I could also achieve the same by putting tries minus equals 1. And this would also do the same thing, but let's include the break statement here to see new syntax included. If I now run this code cell, we once again don't get any option to input any number because tries currently contains 0. So let's rerun the tries variable to set it back to 5, and then rerun the code, and now you can see that we're asked to guess a number. So let's now put in 30. You can see we're too low, so let's put in 40. We're once again too low, how about 65? Too high, 63. Still too high, let's try 60. Better luck next time. So we've now run out of tries and we're getting told better luck next time. And this is great, this is exactly how I want the user to interact with this program. Now I also want to provide the user a little bit more clarity as to how many tries they have remaining. So I'm going to extend the feedback once more. I'm going to go back up to the conditional statements, and where I have put you guessed correctly, I want to tell them how many tries they had remaining. So I'm going to put you guessed correctly, and then after correctly I'm going to put with, then curly braces, then I'm going to put tries remaining, and then I'm going to use the dot format method, and in the parentheses I'm going to pass in the value that's stored in tries. Okay, great, so I can also do this with the failed guesses. So if I go down to the elif statement where it says you guessed too high, try a lower number, I'm also going to put curly braces and then put tries remaining and then use the format method. I can then simply copy and paste this code for the guesses that are too low. So if I reset the tries variable to be 5 and then run the code logic again, you can see that we're asked to guess a number. And if I guess incorrectly, so let's put in 50, you can see that we're now getting feedback telling us that we have 4 tries remaining. Now if I put 3 more incorrect guesses, so let's just put 1, 2 and 3, you can see that we get 1 tries remaining, which doesn't really make sense, but we're going to leave it like this for simplicity. And finally, if I guess 1 more number incorrectly, you can see that we get better luck next time. So the code that we're writing is really coming together now, but I'm thinking there is something we can do to make this more repeatable. What could I do to make code more repeatable? Now, if you're thinking we could put all of this logic inside of a function, you'd be thinking along the right lines. How about we define a function called game_logic and we put this logic inside the body of the function? Let's give it a go. So if we scroll up to our game logic and indent our current code, on the first line of this code cell we can put def, then we can label the function, so we'll call this function game_logic, and then we can put a pair of parentheses. After the parentheses, we can put a colon. Now let's think about this for a second. We can see inside of our function that we use variables called guess, we have a variable called num, and we also have a variable called tries. And we reference these variables straight after the function header in the while expression, before they have been defined inside the function. So if we run the game_logic function in isolation, how do we ensure the variables are defined and do indeed have a value? In other words, where would these values come from? Well, this is where the use of parameters will come in very useful in order to collect the values for these variables. So we know that this function will need to have reference to a variable named guess, which will store an integer. It will also need reference to a variable called num, and finally it will need a reference to a variable called tries. So we can pass these three as parameters to this function. When I now run this code cell, you can see that we don't get asked for anything because at this point we've just simply defined the game_logic function, and we can use this later in our code when we want to call it. That about covers it for our game logic. Let's move on to the final step of our program. We're told that a player should get asked if they want to play the game again or not. If yes, we should replay the game, and if not, we should break out of the game. So to tackle this, I'm going to do something very similar to what we saw in the validating input video. And I'm going to create a function called play_again. I'm then going to put a colon. I'm first of all going to set a variable called again, and I'm going to set this equal to an empty string. I'm then going to put while the value that's stored in the variable again, and we'll take the lower case of this variable, is not in either y or n. Then I want to collect input from the user, which is do you want to play again, y or n? And I'm going to store that result in the variable called again. Now if the value that's stored in the variable again at this point is y, so if again.lower and then put parentheses is equal to y, then I want to return true, because at this point we know the user does want to play again. If again.lower, so using the lower method on the again variable, which we know is a string object, is equal to the lowercase n, then I can return false because we know the user doesn't want to play again. Now if they haven't put in either y or n, we'll go back up to the while loop. It's not in our check, so it's not in y or n, so it would be true, and we would then ask for new input. So if I now run this code cell and then call the play_again function, you can see we're asked if we want to play again. If I put something random like the capital letter T, you can see that we're asked to play again because we don't meet the validation criteria in the function. If I put 5, you can see once again we're asked, do you want to play again? If I put a capital Y, you can see that we return the value true. Now if I recall the play_again function and put the capital letter N, you can see that we now return false, and we can use this logic to pass into our game to decide whether the user wants to play again or not. Okay, so we now have everything that we need in order to construct this game in its entirety. We've tackled each piece of the puzzle individually, but now we can put it all together in our final game play. So the first thing I'm going to do is just kickstart a while loop, a loop which will keep going until we break out of it using the break keyword. And to do this, I can start by putting while true. And because true will always be equal to true, this while loop will continuously loop until we force the program to break out of it. Now in the body of the while loop, I first of all want to set a random number. And we know this is num equals random.randint, and in parentheses we can put 1,100, just like we wrote above. We can also set the variable called tries, and we can set this equal to 5. We know that's an important variable. And because a user hasn't guessed anything at this point, but we do need to store their guess in a variable, we'll set a variable called guess, and we're going to set this equal to a none object. Now this basically means that it doesn't have anything stored in it from the start. It's not a string object, it's not an integer, it's of the none type. Okay, so far so good. I just want to now print out a message to the screen to welcome the user to the game. So I could put print, and then what I'm going to do is use triple quotes so we can span this across multiple lines, and I'm going to put welcome to the number guessing game. You have 5 guesses, so I'm going to tell them up front how many guesses they have. After this, I want to call upon the game logic function. So I can put game_logic, and inside parentheses, we know that this function takes in 3 arguments. The first parameter is called guess, so we need to store the variable guess in this parameter. The second parameter, which is called num, will store the computer's randomly generated number, so we can set this equal to the variable called num, which we've defined above. And the final parameter is tries, and we're going to input the amount of tries that the user has, which we know is stored in our variable called tries. I would then expect this game logic function to do its job, but once we've broke out of this game_logic function's while loop, we want to check to see if the user wants to play again. So we can call upon the play_again function to see what's stored inside. So first of all, let's put play_again and put parentheses. So at this point, if I call this function, it's going to ask for some input, and it's then going to return true, false, or ask for more input until it's either a y or an n, which will then evaluate to either true or false respectively. What I then want to do is put this in an if statement. So I could put if not play_again. In other words, if play_again is false, i.e. the user doesn't want to play again, let's take the reverse of that boolean, which would then make it true, and because the user does not want to play again and this condition evaluates to true, we would then want to print to the screen, see you next time. And because at some point we need to break out of this while loop, and the only time we want to break out of it is if the user wants to stop playing, after this print statement we can use the break keyword. So this is really the engine of our game, and we're simply calling upon logic that we've defined above in order to make the game work. So we're now at the moment of truth, the first time running the program. So let's run this code cell to see what happens. You can see that we first get a message saying, welcome to the number guessing game. You have 5 guesses. Guess a number between 1 and 100. And because this number has been randomly generated as soon as we've run this cell, we don't know what's stored in num. So let's try to get it right. I'm first of all going to go bang in the middle with 50. Okay, I've guessed too high, try a lower number. So let's go 25. Okay, I've also guessed too high, so let's go in the middle, let's go 13. I've guessed too low, try a higher number, 2 goes left. So let's go 18. I've guessed too low, it's got to be between 18 and 25, can I get it right? Let's say 22. Better luck next time, do you want to play again? Yes, I do want to play again, I really want to get this right, so let's go again. So we're going to guess first of all 50, we'll then guess 75. Okay, I'm too high, let's go 65. Too high again, let's go 60. Okay, I'm too high, so it has to be between 50 and 60, let's say 55. Wow. Guess lucky with 55, how lucky, congratulations, you guessed correctly with 1 tries remaining. Obviously the sentence doesn't make sense, but we get the idea. Do you want to play again? I'm now going to put N. You can see that we get a message saying see you next time, and the game finishes. So we've now completed our first full project. We've used conditional statements, we've used variable setting, we've used the random module, we're interacting with the computer with the input function, we're printing out messages to the screen, and we've produced a really interactive game that's actually quite fun to play. Just notice here how we went through each step. We did one thing at a time, and we were just trying to solve for mini problem statements that we then put together in the end in our gameplay section. If there's anything you don't understand in this solution, please feel free to reach out to us in the messages section or the Q&A section, and we'll try our hardest to get your understanding back on track. I hope you enjoyed this mini project, and I'll see you in the next one.